This is the half adder logic gate diagram, and it's formed from two input XOR gates, two inputs AND gates is what forms the half adder logic circuit. So here is the binary addition, and we'll see the output. Okay, it's 1 for the sum, and there is no carry. That's 1 plus 0. And 0 plus 1 is 1 for the sum, and there is no carry. 1 plus 1, 0, carry 1, because 1 plus 1 in binary addition is 10. So this is the half adder circuit. One of the commonly used integrated circuits for implementing a full adder is the 74LS283, which is a 4-bit binary full adder. This IC contains 4 independent full adder circuits within it, allowing it to perform addition on 4 sets of binary inputs simultaneously. Alright, so let me play the simulation and you see how it works. So but first, some of the key features of the 74LS283 is that it operates on a single power supply voltage that is typically around 4.75 volts to 5.25 volts. It has 4 full adder circuits each, and is capable of adding 3 binary inputs, as you can see on screen. Alright, you can see the value of the sum as the output and that of the carry. Alright, now let me do something like this, and then let me add 3 parts. You can see, so this is a full adder. You can see both the carry and the sum is displayed. Alright, another important feature of the IC is that the outputs of each full adder are available individually. As you can see, the sum and the carry, they are available. Alright, so the IC comes in a 16-pin dual inline package form factor. You can see 16 pins. Alright, and it typically operates with a voltage, a supply voltage ranging from 3 volts to 18 volts. It can perform addition operations on 2 4-bit binary numbers, producing a 4-bit sum output and a carry out bit, also having a carry pin for carry in. Alright, so this is just the Proteus simulation of the 4-bit adder.